There was no audio. And he didn't text me, he didn't comment below early. He didn't comment below early. So please, that's why I said you should always share your opinions. If you're having problems, you should comment below so that I will know. Thank you very much for alerting me. This is Diana. She's preparing for NovDec as well. So please try as much as possible to share your opinions. Now let me give you a few minutes, maybe 1 minute, to share it to friends and colleagues and come back to the live session right now. So I'm waiting for you guys. I'm also sharing it on Facebook and WhatsApp, what Brain Insight Academy group. Yeah. So see you very soon. Stay tuned. Peace out. Hello guys. So are you done sharing it with your friends? Let me know in the comment section. Are you done sharing it with your friends so that I will open the camera and then we will start right now? Share it with friends. Share it with
Hello
friends.
guys. So are you done sharing it with your friends? Let me know in the
Let me know whether you are done with it. Let's come this way.
Are you done sharing it with your friends so that I will open the camera and then we will start right now? Share it with friends. Share it with Hello guys. So are you done sharing it with your friends? Let me know in the
Which one more move line? I don't believe you. I hope that for this one, the audio is, you can hear me clearly. Okay. Like it, comment below and let's know whether you can hear me clearly. So that it won't be like the other one. Yes, so let's continue. Let's continue. So I was saying that what you didn't hear me saying, or what you're not hearing me, was that I told you that this is probability falls within in the range 0 to 1. So it can't be more than 0, or it can't be less than 0. It can't be more than 1. So always probability should be in a form of fraction. If it's a whole number, it means that it is what? It is 1 or 0. And it shouldn't be improper fraction. You don't have any probability that is improper fraction. And after that, I told you that probability of when the probability of we have is greater than 0 and also less than 1, that one, it will be in a form of fraction. It's either possible but not certain. It is possible but not certain because it falls within this range. Let's come back to when the probability is 1. When PA, a certain event, is 1, then the event is called certain event, is certain. Then the event is certain. Then the event is certain. Please try to share it with your friends again so that they will join the live session. Try to share it with your friends again so that they will join the live session. If you have any problem concerning the teaching or the camera, let me know in the comment section so that I will know what to do. When you come to, you can like the videos and then comment below so that you can. Okay, so let's continue. So that is it. And the next one that you're coming to talk about is a minute. You won't keep long with this one. I've already summarized everything for you here. Okay. So let's move on to experiments. Now we have probability. Let's move on to experiment whereby we use probability. So the first experiment we're coming to talk about is tossing a coin. Then are you here? Are you here? So the first session we are coming to talk about is tossing a coin. Now when you have a coin, this is a coin. I have a coin here. Oh, I have some coins here. So let's take this coin for instance. This is 2 cedis coin. If you can see me holding it, this is 2 cedis coin. Now the front is called the head, the back is the tail. So when you are tossing a coin, it means throwing it. When you throw a coin like this, you can either have the tail facing you, or you can see the tail or the head. You can't see both sides in one event. So when I say event is like what should I say? Timing, or the time that you used to do something. So this time I'm coming to throw the coin in it. So I've thrown the coin, I've gotten the head. So that is one event. Have you seen? So in this first event, I got the head. This first event, I got the head. So I will use H to represent it. So this is one experiment of probability. You can also get the tail in the second event. So when it comes to tossing a coin, that's how you do. You use H to represent the head. You use tail to represent the head. Do you understand? Okay. Now let's move on to the next one. The next one is also throwing a die. So I don't have a die here, but when you've used a die before. When you throw it, you can either have one of the numbers, either 1 up to 6. So you can have 1, 2, 3 up to 6, right? So that throwing a die too is one of the experiments. And selecting a ball from a bag. When you have a bag there with so many balls, let's take it for instance, if these markers here are balls, you have how many markers? 4 markers. One what? One blue. So if they are in a bowl like this, and you select one, the one that you select is a black. So you have 1 out of what? The total, right? So the 1 out of the total is the probability. 1 4. So 1 out of 4 is the probability. Now let's move on to selecting a student from a class. Now there are 2 categories of students in a class. Can you name them? There are 2 categories of students in a class when it comes to selection of students. A boy and then what? A girl. So you can either select a boy or a girl. So those are the 2 possible students that you can select. Now let's move on to the next one. Selecting a student from, okay, picking a card from a cup. When you are picking a card, we have different colors. Please, a minute. Give me a minute. Okay, guys, I'm back. I'm really sorry. Okay, so I'll start. I'll continue very soon. Then let's sit beside you. Okay, so as I was saying, you be quiet, okay? Yeah, so as I was saying, yes, experiment. So experiment, I've talked about tossing a coin, throwing a die. Then I check if the camera is on me. Is it on me? Can you shift it to be on me? And maybe the board too can come in a bit. But you have it. The board doesn't come in. Can they think this is okay? So that they can see me. Now let's continue. So as I was saying, we have these are the experiments. Now someone will say, what is experiment? What is experiment? So experiment is an action. I have my niece here. I have my niece here. This is my niece. She wants to join me teaching, so let her stand here. So I was saying that an experiment is an action or process that produce a result. So when you say experiment, an experiment is what? An action. Yes, wait, we are teaching here. Okay. So an experiment is an action. Then are you here? One more attention, Bernardo, please. Focus on me, okay? Okay, so an experiment is an action or process that produces a result. Sorry for speaking fancy. Or the result is an action or experiment. So I've talked about all of them. Now let's talk about how to find probability in each of them. When it comes to tossing a coin, when it comes to tossing a coin, I think we should move to this one rather. Let's go into outcome. When you say outcome, the outcome is the possible result of an experiment. So any possible result of an experiment, Inji, where are you going to sit? To this side. Okay, I'll come and pick you. No, I'm teaching here. See, they are watching us. People are watching us from there. So go and sit this side. I will pick you. So where are they? Sit there. Okay. Okay. Good job. So I was saying that an outcome is a possible result. It's a possible result of an experiment. So if you have an experiment, when you toss a coin, the possible result that will come out is what? Then is what? It's an outcome. So what is outcome when you toss a coin? What is the outcome when you toss a coin? Head, and then tail. Okay, let's move on to die. When you throw a die, what is the outcome? 1, 2, 3, 4, 5, 6, right? How about when you, let me see, the third experiment was what? Selecting a ball from a bag. So you have, the number of balls depends on the outcome. So if you have different colors, maybe, let me say you have red, blue, yellow, and green. So if these are the different colors, then this is the outcome. Do you understand? Then this is the outcome. Now let's take it for instance. If you are selecting a student from a class, what is the outcome of the student? What is the outcome of the student in a class? How about the student over the total number of people? What did I say? I said that an outcome is a possible result that from an experiment. Possible result from an experiment. So in a class, we have either boy or girl. So an outcome is what? Either boy and then what? A girl. So that is an outcome. Now when it comes to maybe picking a card from a pack, we have 4 different colors. Maybe let me say for instance you have 4 different colors: red, green, blue. So it's like the ball now. This will be the outcome. Now let's move on to when you say a sample space. What is a sample space? So you can write it down. Definition number, you can write it down. A sample space is a set of all possible outcomes of an experiment. A sample space is a set of all possible outcomes in an experiment. A sample space is a set of all possible outcomes in an experiment. So first of all, what is experiment, Diana? What is experiment? What is experiment? Make a definition for experiment. What is experiment? Did I say something? I said an action or process. An action or process that shows a result. An action or what? Process that does what? That does what? Shows a result. So here is the case that an sample space. When you say sample space, these things they are really important too. When you say sample space, it means all possible outcome of an experiment. So when you throw a coin once, what is the possible outcomes? Head or tail. when you throw a coin twice. So we are coming to list the possible. So this is once. When you throw a coin twice, what would be the possible outcome? So that one, this is how you do it. This is how you do it. So you have, you know how to draw that table? Do you know how to draw that table? So we have head or tail for the first event. The second event, you draw another, this one. Then send it out. Today you are stacking miracle. Hey. Okay, so we have head tail for the first one. The second one, it can be, here can be head tail as well. Head tail. So this is how you write it. Look at here. Then are you watching? This is how you, so you'll be having head or head. So second event can be head, can be what? Head tail. It can be also tail head. It can be also tail tail. Tail tail. So these are the sample space for when you throw a coin twice. Atasa. Do you understand? Yes. So this is the sample space. So we have head head. If you can't see the order, please you can. I don't know. Let me. I don't think they can see it well. Come back a bit. This is okay. Okay. So this is the sample space. This is a sample space for when you throw a coin twice. Now let's check when you throw a die once. What will be the sample space? Can you give me the sample space of a die? Can you give me the sample space of a die? So we have one. So once we have 1, 2, 3, 4, 5, 6. How about when you throw two dice together? When you throw two dice together, the sample space. So this is how you do it. Simple way to do it. You draw a square whereby you divide it into 6, like this. So you divide it like this. Then you write, oh shit. Okay, maybe this is another one. So you write, here will be, maybe you can have here 1, 2, 3, 4, 5, and then 6. And then 6 to be here. Have you seen? Then you have here the same thing. 1, 2, 3, 4, 5, 6. If you can't see the board clearly, you can check in your textbooks there. You have them in. So this is how you get the result easily. So you can here will be what? 1, 1. Here will be what? 2, 2. 2, 1, 2, right? 1. So here is going to be 1, 1. Here is going to be what? 1, 2. Can you see it? So the column, that's how you get it. Now let's check out the sample space for I think the sample space, you're okay with it, right? So let's move on to event. When you say event, what is an event? Event is an outcome or a collection of outcomes that we are interested in. So that is event. So what is event? They are outcome or collection of outcomes that we are interested in. Yeah, event. So that is event. Oh, someone is saying he's watching from India. Wow. Far away from here. We are from Ghana, yeah. Someone is watching from India. So that is event. When you say event, event is an outcome or collection of outcomes that we are interested in. So it's not always it's not always it's not all the outcomes that we are interested in, but the few outcomes that we are interested in is the event. Do you understand? Do you understand? So let me give you an example. So let me see. When you throw a dice, when you throw a dice, when you throw a die, we got when you throw a die and you get 1, 2, 3, 4, 5, 6. When you throw a die and you get 1, 2, 3, 4, 5, 6 as your sample space, and you are asked to find a, let me say, they can ask you to find a probability of getting an what is going to be the event? Pardon? What? Oh, say it, try. No. What did I say? I said that an event is an outcome or collection of outcomes that you are interested in. So this is the outcome from throwing a die, right? This is an outcome from throwing a die. So since this is an outcome from throwing a die, what is going to be the one we will be interested in, since they are asking us the even numbers? Not the sum of all the even numbers itself. So now we are going to have our event to be, so our event is going to be what? 2, 4 and 6. So that is what you are interested in. Do you understand? Please, when I say atas, it means that, do you understand? So our event is that. Now, after obtaining the event, they can ask you to find the probability. So here is the case. When you're asked to find the probability of getting an even numbers, it will be the number of even numbers out of the number of what? The total. Do you understand? So probability is going to be the number of even numbers out of the number of what? The total. The number of even numbers out of the number of the total. So what is the number of even numbers? We have 3 here. So it's going to be 3 out of what? 3 out of what? 6. Then we break it down. We are going to get 1 out of 2. 1 out of 2. We are going to get 1 out of 2. So that is it. We are going to get 1 out of 2. Do you understand now? Do you understand? No, this one is not mean and median. No. We have a probability. This is not mean and median. So this one we are finding probability. In other words, when you are asked to find probability of any number or a certain number, is the number of events. Let me put it that way: number of events or number of what they are asking for out of the total. That is basically how probability works. For instance, if say if you're having 4 cards, which you have, maybe we have blue, green, yellow, and red in there, and we are asked to find the probability of getting a blue card. Now, how many blue cards are in there? Oh, but you have 4 cards, and I said you have blue, this one. So these are the number of cards. We have blue card, we have green card, we have yellow card, we have red card. So what is going to be the probability of getting the blue card? 1 over 4, 1 out of 4. So you're going to have, so probability is equal to the number of blue card out of the number of what? The total. Do you understand? Number of blue card out of the number of what? The total. That is it. Now let's move on to next session. Do you understand this one now? Yeah, so when they ask you to find probability of everything, that's the basic one that you've learned from JHS and other things. So here, when I ask you to find the probability of getting a prime number from this outcome. Look at here. When I ask you to find the probability of getting a prime number from this outcome, what is going to be the what is going to be the event? What is going to be the event? Is one a prime number? Is one a prime number? Hey. So we are going to have 2, 3, and 5 as the event. That is the outcome we are interested in. Then after that, what will be the probability? 3 on 6, which is what? Which is 1 on 2. Fantastic. Fantastic. So let's move on to probable outcome that satisfies the condition in the question. Okay, so I think we are done with this one. So in first place, if you have to find probability, basic probability, this is how to find it. If you have to find probability is equal to, are you watching? Probability is equal to let me say probability is equal to, maybe probability of A is equal to the number of A. Are you watching? The number of A out of the number of what? Total, or out of the number of the sample space. Yes. Do you understand? So this is basic probability. Now let me try with this question and let me see if we can able to solve it. Okay. A fair die is thrown once. A fair die is thrown once. A fair die is thrown. This is a simple question, so you can just check if you can get the answer. A fair die is thrown once. Find the probability of obtaining 5. Obtaining 5. 1 out of 6, fantastic. 9. That's all. Okay, a fair die is thrown twice. A fair die is thrown twice. A fair die is thrown twice. Find the probability of obtaining an even number. Even number if a fair die is thrown twice. No, it's only and once more simple because twice are not the table. Do you understand? So let's do it. A fair die is thrown once. So probability of finding an even number, you have it. 3 on 6, which is 1 on 2. That's all. Okay. I think all these questions I've asked you already. Okay. Now let's move on to equally likely outcomes. Equally likely outcomes. You can write it. Equally likely outcomes. Equally likely outcomes. Let me check the time. Equally likely outcomes. Okay. Equally likely outcomes. So it's a subtopic on its own. Now, outcomes are equally likely. Outcomes are equally likely when each outcome has the same chance of occurring. You have to write it down. Outcomes are equally likely. They are equally likely when each of them have the same chance of obtaining, or let me say, or occurring. So, for instance, if we have this one, if we have this one, a feather. When you throw a feather, we have 1, 2, 3, 4, 5, 6. So all of them are equal to. Let me say we can get any of them, right? Right. Do you understand? So this example equally likely outcome. Do you understand? Because we can get 1, we can get 2, we can get 3, we can get any of the numbers at each. Which one? Down here. I said probability of maybe A. When I find probability of A is the same as number of the A over number of sample space. Do you understand? No, me, I'm saying the equally likely outcome is this one. That one is where, thank you. So equally likely outcome. That one is where we have let me see 1, 2, 3, 4, 5, 6 on a die. When you throw it, you can get 1, you can get 2, you can get any of the numbers, right? So they are all equal to come out. Do you understand? That's what it means. Now when we move to I think I have to explain this one before. So experimental probability, that one is based on, or let me read what is here for you before I explain it. Experimental probability is based on the actual result obtained from an experiment. It's based on what? The actual result obtained from an experiment. So if you have probability A, it will be equal to the number of times A occurs. The number of times A occurs out of the number of times of trials. Do you understand? So example, when you have this question, a coin is tossed 40 times. A coin is tossed 40 times. And the head occurs 23 times. Have you seen? Head occurs 23 times. They can ask you that, what is the probability of obtaining the head? What will you do? What will you do? You are not here. Listen to what I'm saying. I'm saying that experimental probability, for that one, we use the number of the thing occurs. So for instance, they can ask you that a coin is tossed 40 times. A coin is tossed what? 40 times. And then the number of occurrence for head only is 23. So what is the probability of finding, what's the probability of obtaining the head? It will be what? Okay, so write it experimental probability. So for instance, if you have experimental probability, PA is equal to the number of times of A occurs, number of times of A occurs out of number of times of trials, out of number of times of trials, out of number of times of trials. So we are talking about A. Now I said that in the experiment, a coin was tossed 40 times and the head obtained what, 23. I mean, it occurs 23 times, right? Right? So if it occurs 23 times, what is going to be the probability for the coin or the head? 40. If we're listening to me and better, you're thinking of different things. This is very simple. Okay, what will be the probability of obtaining the tail? What will be the probability of obtaining the tail? So it will be the number of times of the tail out of the number of trials. So how are you going to do it? Out of the number of trials. I know you are not here. Hey, but you don't get what I'm saying. But I didn't give you anything. If you are throwing a coin and you don't get a tail, you get the head. That the rest will be what? So this one, I shouldn't tell you that the tail is this. So what will be the tail? Number of times of the tail. I know that it's tail over the number of trials. So what will be the number of the tail? Why one? You see, you're not paying attention at all. Yes.
So the number that you gave me is the one that I should use.
Now, what I tell you, if let me pause this thing. Let me try the pack. You're not paying attention at all. Because this thing, no one will get this question wrong. Okay. So that is it. So if now when you find the number of tail, let me see, it's going to be 40 minus 23, right? So if 40 minus 23, you're going to have tail to be what? 17. Do you get me? You're going to have tail to be 17. If the number of tail is 17, what's the probability of finding the number of tail? 17 over 40. Now let's move on to the next one. Um, so that was experimental probability. Let's move on to complement of an event. Complement of an event. Let's move on to complement of an event. Now, the complement of an event means that the event does not occur. The complement of an event means that the event does not occur. Do you understand? The complement of an event means that what? It means what? So if the event does not occur, so if you have complement A, let me erase this one. If you have complement A like this, if you have probability of complement A, it means that you are going to get it since total probability is 1. Are you listening? Since total probability is 1, it means that you are going to get it as 1 minus if it is occurring. Do you understand? Do you understand? Probability of event A, complement A, it means that this one is not occurring. This one is not occurring. So if it is not occurring, when we deduct when it is occurring from 1, or let me say when we deduct the number that we have from 1, that will be that it means that this is not occurring. Do you understand what I'm saying? Do you understand? Okay. So for instance, if you have maybe probability A to be equal to 1 out of 3, if you have probability A to be equal to 1 out of 3, and they ask you to find probability complement A, are you watching? Probability of complement A, what is going to be the answer? So 1 minus 1 out of 3, which is what? 2 out of 3. So that's what we're going to have. So that is complement for you. I'm clear. Do you understand? Okay. Words that may indicate complement. I listen. When you talk about these words, when you see these words in the question, it means that it is a complement. When you see these words, it means that it's a complement. One is not, not, not. One is not, N-O-T. When you see not in probability question, it means that it is a complement. When you see does not, it means the same thing. Complement. Does not. When you see fails, 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 it also means complement. When you see none, when you see none, N-O-N-E, it means complement. When you see neither, neither, it also means complement. When you see doesn't occur, doesn't occur, it also means complement. Doesn't occur. Indy, what's wrong with you? Huh? Indy, what's wrong with you? Come, come. Mommy, come. What's wrong with you? Don't cry, don't cry. Okay. Okay, so for instance, if you have the probability that Kofi passes a test is 0.8. Find the probability of, I'm giving a question out too. So we can write this as an example. The probability that Kofi passes a test is what? 0.8. The probability that Kofi passes a test is 0.8. Then be hurry with your things. So now find the probability that he does not pass the test. You want to sit here. Which is what? Which is what? So 1 minus 0.8. 1 minus 0.8. Hey, you don't know. Hey, it's like 1 minus 1.0, 0.8. You are deducting, you don't know. So it's like 10 minus 8. What is 10 minus 8? Eh, so that is it. Sit there, okay? Sit there and wait for me. That is it. So the answer is 0.8. Now let's go on to mutually exclusive event. Mutually exclusive event. Mutually exclusive. You are in class, so yo. Let's move on to mutually exclusive event. Mutually exclusive. Then please put the phone down. Put the phone down. Put the phone down. Oh, but what I'm teaching is very important. Okay, mention my. After that, you tell me you don't understand. Simple question for a betting. Yo. So when we talk about mutually exclusive events, two events are mutually exclusive if they cannot happen in the same time. Two events are mutually exclusive if they cannot happen in the same time. So what is mutually exclusive event, Diana? Teacher, when they cannot happen at the same time. Okay, so that is That is mutually exclusive for you. For instance, let's see this one. Once a die is thrown once. A die is thrown once. You have to write the example. A die is thrown once. A die is thrown once. Guys, please, I'm really sorry. Let me set the camera. Oh. Unless I